Hello, hi everyone. Welcome to my YouTube channel. And in today's video, we're going to solve the past paper of the October-November 2024, which is paper 2. So let's start. In the first question, it is saying that different electronic configuration of the atoms are given to you, and you have to use them to answer the following questions. In the first part, it is saying that an atom of a noble gas. So as you all know that the noble gases are present in the group 8 of the periodic table, and these elements have their complete outermost shell with the 8 electrons present in them. So out of this, you can see in the option B, this is the large shell and already the 8 electrons are present. So B is the answer. An atom of an element that is used in food containers because it is resistant to corrosion. So you have studied in the chapter of the metals that there is one element which is aluminium, and aluminium is a metal which has already a protective layer surrounding it, right? And that protective layer is of aluminium oxide, and this protective layer of the aluminium oxide prevents the aluminium to get easily corroded. So this is the protective layer of Al2O3, and this will not allow the aluminium to get corrode easily. So that's why we can use the aluminium in the food containers. So you have to identify that which element out of these is showing the electronic configuration of aluminium. So for that you have to use the periodic table, and in the periodic table you can refer and see over there that the atomic number of aluminium is 13. So its electronic configuration is 2, 8 and 3. So here you can see that the element E is showing the electronic configuration similar to 2, 8 and 3. So the answer for this one is E, which is the aluminium atom. In the next one, it is saying an atom of an element in group 5 of the periodic table. Group 5 means that it would be having 5 valence electrons, because group number shows you the number of valence electrons. So out of these 5 elements, you can see that in the option D there are 5 valence electrons, right? So option D is the correct answer. Now in the next part, it is saying that an atom of an element in the period 3 of the periodic table. Now the period number tells you about the total number of shells which are present in an atom. So you have to see that which element is having the total 3 number of shells. So the first one is not, the B is not also. In the option E again, you can see there are 3 shells, 1, 2 and 3. So it means that it would be present in the third period of the periodic table. So E is again the answer. An atom that forms a stable ion of the charge 2 minus. So those atoms 2 minus means that it has gained 2 electrons. So an atom which will be gaining the 2 electrons would be the one which would be having 6 valence electrons. So it would be needing 2 more electrons, that's why it is gaining 2 electrons having a charge of 2 minus. So you have to see that which element has 6 valence electrons right now. So you can see in the option C we have 6 valence electrons. So it would be gaining 2 electrons to get a charge of 2 minus. So that's why option C is the answer for this. Now in the next question, it is saying that deduce the number of protons and neutrons in the vanadium atom. So this is the vanadium atom, and the subscript is written 23. So this is your atomic number, and 51 is your mass number. Okay. So atomic number is 23, which also represents the number of protons. So number of protons are 23, and for number of neutrons, just simply subtract the mass number, atomic number from the mass number, right? So you will be getting 28. So these are the number of neutrons. Now question number 2, this question is related to the extraction of the iron. So iron is extracted in the blast furnace by the reduction of iron 3 oxide. This process includes 3 steps. So if you can recall the steps which are used in the blast furnace, right? So here it was like this, that you have this blast furnace, and in the blast furnace you add the raw materials into it, the raw materials for the extraction of iron were three raw materials. The first one was coke, which is carbon. Then you have the iron ore, Fe2O3, and the third one was limestone, CaCO3. So these three were your raw materials. And from the bottom of the blast furnace, you pass the hot air or the oxygen gas, right? So in the first step, what happens? The carbon burns in the air to produce the carbon dioxide. So carbon burns in the air to produce carbon dioxide. Okay. So give one other reason why carbon is burned in the air in the blast furnace. So basically, why we are doing the oxidation of carbon? Why we are producing carbon dioxide over here? So the reason was that when the carbon will burn with the oxygen, okay, so it will be an exothermic reaction, and because of this exothermic reaction, a lot of heat energy will be produced over here. Okay, when the carbon and oxygen will be burned over here to produce carbon dioxide, so it will be producing a high temperature or high amount of heat energy because it is an exothermic process, and that high temperature will be utilized. That high temperature will be utilized to decompose the calcium carbonate, CaCO3, which will be further used to remove the impurities. So that's why we need a high temperature, and that's why we are oxidizing the carbon or the coke in the first step. So the answer would be to produce the heat or to create the high temperature in the blast furnace. That's why we are oxidizing the carbon. In the second part, it is saying in the step number 2, the carbon monoxide is produced by the reaction of carbon dioxide and carbon. Now in the first step, as the carbon dioxide gas is produced, so this carbon dioxide gas will now react with the further coke. Carbon dioxide gas will react with the further coke, which is your raw material, to produce the carbon monoxide gas. Okay. So they are asking adverse one effect of the carbon monoxide on the health. So we know that carbon monoxide is a toxic gas or it is a poisonous gas. So that is the harmful effect on the health. Now in the step number 3, as soon as this carbon monoxide gas will be formed, so this carbon monoxide gas which is produced in the step number 2, it will react with your iron ore, which is iron 3 oxide. So you have to write the equation for that. So iron 3 oxide, Fe2O3, will react with the carbon monoxide. So this carbon monoxide gas will do the reduction for this iron ore. So in the reduction, what will happen? This Fe2O3 will be reduced to form iron, Fe, and along with the carbon dioxide gas. Now you have to balance the equation over here, so it will be 2Fe, and in order to balance the oxygen and carbon, so if you place 3 over here and 3 on this side also, so it will be balanced. Now in the part B, it is saying explain why calcium carbonate is added in the blast furnace. So you can see CaCO3 was your raw material. So why we are adding calcium carbonate? One of the purpose of adding the calcium carbonate is to remove the impurities from the iron ore, right? So in the iron ore, which is Fe2O3, you have the impurity. Some impurities are present inside the iron ore, and that impurity is your silica sand, which is SiO2. So you want to remove this impurity from the iron ore in the blast furnace. That's why you are adding calcium carbonate. Now the question is how this calcium carbonate will be able to remove this impurity. So the steps or the process is that, okay, first of all, this calcium carbonate which you are adding in the blast furnace, it will be decomposed to form calcium oxide along with the carbon dioxide gas. And now in the second step, this calcium oxide which is being produced by the decomposition, it will be getting reacted with your impurity, which is silicon dioxide. This impurity is present in the iron ore, so it will be react to form calcium silicate, and calcium silicate is your slag which will settle down, at the bottom of the blast furnace, and you can easily separate that slag out of it. So the basic purpose of adding the calcium carbonate was to create this slag which will ultimately remove the impurity. So what are the two steps? The first step is your decomposition. First of all, what you will do? Decomposition of calcium carbonate. to form the calcium oxide. Okay, decomposition of calcium carbonate to form calcium oxide. And in the second step, this is your second step, right? Step number 2. So in the second step, what we are doing, calcium oxide reacts with silicon dioxide, which is the impurity, to form the slag, which can easily be removed from the bottom of the tower. Now in the next question, it is saying that iron is a transition element. Transition elements have high melting at boiling point. So one of the property related to the transition element is already given. State 2 other properties which are typical to the transition elements only. So you have to mention those properties which are only applicable to transition metals and not applicable to the group 1 metals. So we know that the transition elements have very high density, but the group 1 metals have low density. Similarly, transition elements can act as a catalyst in the different reactions, but the group 1 elements cannot act as a catalyst. Similarly, transition elements have variable oxidation numbers or oxidation states, but the group 1 elements have a fixed oxidation number, which is +1 only. Okay, and similarly, transition elements can form the colored compounds. So you can write any one of 2 of the properties out of it, because it's a 2-mark question, so you just have to mention only 2 of them. Now in the next question, it is saying that iron is prevented from rusting by galvanizing with zinc. So in galvanization, what we do, we do the coating of the zinc on the iron, so in order to protect the iron from rusting. So iron Fe is being protected from the corrosion by galvanizing with the zinc. So you create a protective layer of zinc around it. So this is the protective layer of the zinc which will prevent the iron from getting rusted. So explain 2 different ways in which the zinc prevents the rusting. So how this zinc is preventing the rusting of iron? So it's very obvious that zinc is creating a protective layer, right? And because of this protective layer, what will happen? The oxygen gas or the water will not come in contact with the iron, because for the corrosion, oxygen and water are necessary. So since there is a protective layer of the zinc, so this oxygen and water cannot come in contact with the iron easily, and that's why iron cannot be get corroded. So what basically zinc is doing? So zinc is creating a protective layer. Zinc is creating a protective layer that do not allow oxygen or water to come in contact with iron. So in this way, the iron will be prevented from corrosion. And similarly, let's suppose that, for example, if in any of the case from anywhere this protective layer is being damaged, and if oxygen and water comes in contact with the iron, then still also the iron will not be get reacted because of the less reactivity of the iron, right? And if you look at the reactivity series, so in the reactivity series you will find that the zinc is more reactive than iron. So when you go down the reactivity series, iron is below the zinc. So since zinc is more reactive than iron, then what will happen? That zinc will get corrode easily and iron will not, right? Because zinc is more reactive. So if in case, for example, the oxygen and water are coming in contact with the iron, if this protective layer gets damaged in any of the case, right, then still also the iron will not get corrode because zinc is more reactive than iron. Okay, so since zinc is more reactive than iron, so zinc will corrode, zinc will react with the oxygen and water, instead of iron. So in this way, the iron will be prevented from getting rusted. Now in the part E, it is saying that this equation is given to you, which is a reversible reaction, and in this reversible reaction it is saying that predict and explain what happens to the position of equilibrium when the pressure is increased. So you must know the rule for the pressure, that by applying the pressure, in which direction the equilibrium gets shifted. So the rule is that by increasing the pressure, the equilibrium will move in that direction which has less number of moles of the gas. So I am writing the rule over here. By increasing the pressure, the equilibrium will shift in that direction which has less number of moles and that mole should be of the gas, okay, because the pressure only impacts the equilibrium in which the gases are being involved. It has no impact on the solid or liquid. It only impacts on the gases only, because by applying the pressure only the volume of the gas can be varied or changed, but by applying the pressure the volume of the liquid and the solid do not get changed. So that's why the pressure is only applicable to the gases only, okay, and this rules apply for the gases only. So in this equation you can see that on the reactant side the iron is in the solid form. It means that pressure won't be having any impact on the iron. The second reactant is your water, but it is in the gaseous form. So how many moles are there? 4 moles are there. Similarly, on the product side, Fe3O4, it is in the solid form, so pressure won't be having any impact on this. Hydrogen is a gas, so its moles are also 4. So the rule was that by increasing the pressure, the equilibrium will shift in that direction which has less number of moles of the gas. But over here you can see the moles of the gas are equal. 4 moles on the reactant side and 4 moles on the product side of the gas. So it means that pressure will be having no effect, because the moles are same on both the sides, because the moles of gas are equal on both sides of chemical equation. Now in the next question it is saying that Fe3O4 reacts with the concentrated hydrochloric acid. The products are iron 2 chloride, iron 3 chloride and a liquid that turns the cobalt 2 chloride paper pink. Construct the symbol equation for this reaction. Now you have to create the equation. So the reactant is given to you, which is Fe3O4. It is saying that it reacts with the concentrated hydrochloric acid. So hydrochloric acid is your HCl. So as it will react, it will be forming iron 2 chloride. So iron 2 chloride means that iron has an oxidation number of +2. So iron 2 means Fe +2, and chlorine is in group 7, so it has a charge of oxidation number of -1. So when you will cross multiply it, you will get FeCl2. So one of the product is your FeCl2, iron 2 chloride. Then we have iron 3 chloride. Iron 3 chloride means iron has an oxidation number of +3. Cl again -1, cross multiply. You will be getting FeCl3. And the liquid that turns blue cobalt 2 chloride paper pink. So they are not giving you direct name of the liquid which is being formed. They are giving you the identification test for that liquid. And that test is that that liquid will turn the blue cobalt 2 chloride paper pink, and this is the test for a liquid which is water, H2O. H2O is that liquid which turns the blue cobalt 2 chloride paper pink. So basically it is water. So now you have to balance this equation. So in order to balance the equation, you can see iron is 3 over there, So, and on the product side it's 2, so you can place 2 over here. And now in order to balance the chlorine, 3 2s are 6 and plus 2 8, so you can place 8 over here, and 8 hydrogens on the reactant side. So for the product you can place 4 over here, so this equation will be balanced. Now in the question number 3, it is saying that figure 3.1 shows the apparatus used for the electrolysis of the dilute sulfuric acid using the graphite electrodes. So dilute sulfuric acid is your electrolyte, so it means that it has the ions H plus SO4 minus 2, and from the water, since it is dilute, so it would be aqueous also, so from the water you will get the ions of H plus and OH minus. Using the graphite electrodes, you know that the graphite electrodes are made up of carbon, and these electrodes are your inert electrodes. Inert electrode means that they will not take part in the chemical reaction, or they will not take part in the electrolysis. So first of all, in the part A, it is saying that define the term electrolysis. So in the electrolysis, what you do, you pass the electricity or the electric current from your electrolyte. This is your electrolyte, and as soon you will pass this current or electricity from your electrolyte by using these electrodes. So what will happen? This electrolyte or the ionic compound will get decomposed. How it will get decomposed? That the cations will go to the cathode, anions will get at the anode, and they will get discharged over there. So basically what is happening? Your electrolyte or the ionic compound is getting decomposed, right? And that is what the electrolysis is. So electrolysis is the decomposition of an electrolyte. An electrolyte means your molten or aqueous ionic compound. This is your electrolyte. So decomposition of your molten or aqueous ionic compound by passing electric current through it. Okay. Now in the part B, it is saying that label the anode. Now anode is your electrode at which the anions will get discharged. So at the anode, so you can remember by this term that anode means anion. So anodes, anions go at anode and get discharged over there. So anions are your negative ions, right? What are your negative ions over here? Sulfate ion and hydroxide ion. So sulfate ion and hydroxide ion, which are your anions, they will go at anode, right? So if the negative ions are going at the anode, so it means that the anode should be positively charged, because anions are negatively charged, so negative ions will go to the positive electrode. So positive electrode is your this one, right? This is your positive electrode, so this will be your anode, which is your positive electrode, and over here the negative anions will go and discharge. Now in the part C, it is saying that name the product at cathode. So at the cathode, the cations will be going over there. So this is your cathode, which is your negatively charged, and the cations, which are positively charged, will be going over there. So at the cathode, these are your cations. Cations is your this one, H plus ions. These are your cations, and they will go at the cathode. So at the cathode, what will happen? These cations will get reduced over there. They will be gaining the electrons. So when the H plus ion will go at the cathode, it will gain the electron to form hydrogen. But hydrogen, you know that it is in the form of diatomic gas. So 2 H plus ions will gain 2 electrons to form the hydrogen gas. So hydrogen is your product at the cathode. Now in the next part, it is saying that oxygen is formed at anode. So oxygen is forming at anode. Construct an ionic half equation for the reaction at anode. So at the anode, the anions would be going over there. So you have two anions, sulfate ion and hydroxide ion. And you have studied that this sulfate ion, whenever this sulfate ion is present, it will never get discharged. Sulfate ion never gets discharged at anode. So now you are only left with hydroxide ion, OH minus ion. So this hydroxide ion will get discharged at the anode. So you have to form the equation for that. So the equation is K hydroxide ion gets discharged at the anode to lose 4 electrons, and after losing 4 electrons it would be forming the oxygen gas along with the water H2O. So you can see oxygen gas is being formed, and it was already mentioned in the question also. Name a suitable element other than graphite that is used for the electrodes in the electrolysis. So as I have told you earlier that graphite electrode is your inert electrode. So other than graphite, which inert electrode can we use? So we can use the electrode of the platinum also, because platinum is also a inert element, so that can also be used as the electrode. Now in the next question, question number 4, it is saying that this question is related to the organic chemistry. In this question, it is saying this question is about the alkanes and alkenes. Butane belongs to the alkane homologous series. Members of the same homologous series have same functional group and the same journal formula. So two of the characteristics are given to you of the homologous series. Okay, all the members in the homologous series have same functional group, and all the members of the homologous series have same journal formula. For example, for the alkanes, if you want to make the homologous series of alkanes, so what is the general formula? CnH2n plus 2. For alkene, what is the general formula? CnH2n. Right? Now they are saying that state two other characteristics of the homologous series. So when you form any of the homologous series, right? So one of the characteristic is that in the homologous series, all the members have same chemical properties. Yes or no? Okay, they have same chemical properties. For example, if you form the homologous series of alkanes by using this formula CnH2n plus 2, so the homologous series you will be getting CH4, C2H6, C3H8 and so on. This would be the homologous series for alkanes. So as you will go down the group, right? If we talk about the chemical properties, so all these will be having same chemical properties. Why they have same chemical properties? Because they have the same functional group. Because chemical properties depend upon the functional group also. So since they have same functional group, so all the members will be having same chemical properties. Now if we talk about physical properties, so physical property means melting point, boiling point, flammability and all that. So if we talk about physical properties, so the physical properties are not same, but the physical properties show a smooth trend. For example, if we talk about melting and boiling point, so melting and boiling point get increases down the homologous series. Similarly, another physical property is your viscosity. So viscosity also increases down the homologous series. Another physical property is your flammability. So flammability gets decreased down the homologous series. So you can see all the physical properties show a smooth trend, right, down the homologous series. So you can write this property also, physical properties show a smooth trend. Either the physical property will be increasing or decreasing down the homologous series. So that is also a characteristic. Now in the part B, it is saying that this is the displayed formula of butane. Explain how figure 4.1 shows that the butane is a saturated compound. Now the saturated compounds are those compounds in which you have all the carbon-carbon bonds as a single covalent bond. So here you can see all the carbon-carbon bonds are single. So that's why it is a saturated compound. If there would be any double bond in between the carbon atom, then it would be a unsaturated compound. Right? So right now all carbon-carbon bonds are single covalent bond. That's why it is a saturated compound. In the next part, it is saying that give the structural formula of butane. A structural formula means that you have to show all the carbon atoms separately, but the hydrogen atoms attached with each carbon will be condensed or combined together, right? So look at the first carbon. It is having 3 hydrogens, so we will condense all 3 hydrogens. We will write CH3. Okay. Similarly, another is your carbon is having 2 hydrogens, so CH2. Then next carbon also having 2 hydrogens, CH2, and the last one is having 3 hydrogens, so CH3. So this is your structural formula. In the next part, it is saying that nonane C9H20 is present in the naphtha fraction in the distillation of the petroleum. So this question is from the fractional distillation of crude oil. So state one use of the naphtha fraction. So it's very simple that naphtha fraction is used as a chemical feedstock for the preparation of the different chemicals in the industry. So you can use naphtha as a raw material for making the different chemicals. Nonane is cracked, a shorter hydrocarbon molecules are formed. Now this question is related to the cracking, in which the long chain hydrocarbons are cracked to form smaller chain hydrocarbons, right? So construct a simple equation in which the nonane is cracked. Now the nonane is your C9H20. So nonane is your C9H20, it is given to you, and you have to do the cracking. Now the cracking, in the cracking you are forming the shorter hydrocarbons, and the shorter hydrocarbons are given to you. One is your the propane and the another one is your ethane, and these are the only products which are being formed. So when C9H20 will be cracked, so you are getting propane. Now propane is a member of an alkane series. Propane means 3 carbon atoms, prop. So CnH2n plus 2. So you can get the formula by putting the 3 over there. So you will be getting C3H6. So this is the formula for propane, C3H6. Then we have ethene. Ethene is a member of alkene. Alkene is CnH2n. Ethene means 2 carbon atoms. So you have to put 2 over there. So you will be getting C2H4. So you are getting C2H4, right? Now you can see this equation is not balanced. Okay. So in order to balance the equation, here you can see there are 9 carbon atoms, but over here we just have 3 plus 2, 5 carbon atoms. So in order to balance and make it 9, if I put 3 over here, so it will become 3 to the 6 plus 3, 9, and the hydrogens are also balanced, 4 3s are 12. Okay, and then you have this one, which is, sorry, this one would be propane. Propane is C3H8, sorry, if you put 3 over there, 2 3 are 6 plus 2 8, so propane is C3H8, not C3H6, C3H8. So the hydrogen is also balanced now. So this is your propane, C3H8. This is your ethene. Now in the next question it is saying that propane reacts with the chlorine in the presence of the ultraviolet light. Figure 4.2 shows the displayed formula of the reactants and the product. So this is the equation which is given to you. Name the type of the chemical reaction that takes place. So in this one, you have to mention the type of the reaction which is taking place over here. So here you can see the hydrogen was over here, and this hydrogen is being replaced by the Cl. So what is basically happening? This Cl2, one of the chlorine, is substituting this hydrogen, right? It is replacing the hydrogen, and when the H will come on this side, it will be forming HCl, and when the Cl will go on that side, so you will be getting this product. Okay, so name the type of the chemical reaction. So this type of chemical reaction is called substitution reaction, in which the hydrogen is being substituted by the chlorine atom. State the purpose of the ultraviolet light in this reaction. Now for this reaction there is a condition that you have to provide a sunlight or the ultraviolet radiation. Now what basically this sunlight is doing? Without this sunlight this reaction cannot proceed. This reaction will not take place. So what is the reason for that? The reason is that without sunlight this reaction won't be having enough activation energy to get performed. And what is activation energy? You all know that activation energy is the minimum amount of energy that is required by the reactants to convert into products. So in the energy profile diagram, this is your activation energy. So this is the minimum energy, this is the barrier. If you want to convert the reactants into products, so this is the barrier for you, right? If the reactants want to go into the product side, so this activation energy must be present, otherwise they cannot convert into product. So this energy needs to be gained. This activation energy is the minimum energy that needs to be gained by the reactant to convert into product. So for this reaction, the activation energy is not present if you are not giving the ultraviolet light. So this ultraviolet radiation will help you to will help the reactants to achieve the activation energy, to gain the activation energy, so that they can easily be converted into product. So this ultraviolet light gives or provides the activation energy to the reactants, so that they can easily be converted into product. Now in the next question it is saying that calculate the enthalpy change. You have to calculate the delta H enthalpy change by using the bond energies for this particular reaction. So if we want to calculate the enthalpy change, for enthalpy change we have to use the formula bond energies of reactants plus bond energies of the product. So when you will sum up bond energies of the reactants and the product, so you will be getting the enthalpy change. So if you want to calculate the enthalpy change, so first of all you have to see on the reactant side. On the reactant side, what will happen? On the reactant side, the bond breaking will take place, right? Bonds will be going to break, and when the bonds will be break down, the new bonds will be formed, and the new bonds will be forming in the product side. So you have to calculate the bond energy, bond breaking energy, which is on the reactant side, bond energies of the reactant, which is bond breaking energy, right? And you have to sum up with the bond energy of the product, which is basically your bond formation energy. So in order to calculate the delta H. So first of all, we will be going to calculate the bond breaking energy of the reactant. Bond breaking energy of reactant. So for that, what you have to do, you have to see that how many bonds are present on the reactant side. So on the reactant side, you can see first of all that the bonds which are present on the reactant side are your carbon-carbon bond. Okay, this is your carbon-carbon bond. This is again your carbon-carbon bond. So how many times carbon-carbon bond is present? 1 and 2. 2 times this bond is present, which is the carbon-carbon bond. Okay. Similarly, count the carbon-hydrogen bond. Okay. So first of all, if we look at the carbon-carbon bond, so there are two times. So the bond energy is given to you, which is 347. So 347 is the bond energy for one carbon-carbon bond. But on the reactant side, you have 2 times this type of bond. So 2 multiplied by 347. Okay, now on the reactant side you can see another type of bond, which is carbon-hydrogen bond. So carbon-hydrogen bond is how many times? 1, 2, 3, 4, 5, 6, 7 and 8. 8 times. So 8 multiplied by energy of the carbon-hydrogen bond, which is 413, plus then we have Cl. The another type of bond is this one, which is on the reactant side, which is this Cl and Cl bond. And the bond energy for that is 243. So plus 243. So this would be the total energy which is associated on the reactant side. So you have to sum it up, the total energy on the reactant side, which would be 2 multiplied by 347 plus 413 multiplied by 8 plus 243. So you are getting 4241 kilojoule per mole. Now this is the energy of the bond breaking, and whenever you break a bond, so bond breaking is endothermic because the energy will be absorbed to break down the bond. So bond breaking is the endothermic process, right? So it would be associated with the sign of the plus. So this is the energy of the bond breaking. Now similarly, if you look at the bond formation energy of product. So on the product side, right, if you count the bonds again, so you have the carbon-carbon bond, your carbon-carbon bond. How many times? 2 times the carbon-carbon bond is present. So again 2 multiplied by 347 plus. Then we have carbon-hydrogen bonds. Now carbon-hydrogen bonds are 1, 2, 3, 4, 5, 6 and 7. 7 times. So 7 multiplied by 413. Now you have to check another type of bond on the product side, which is the C and Cl bond. The C carbon and chlorine bond is only 1 time. So this is 346. So plus 346 plus. Now you have HCl bond, H and Cl bond, which is 432. Right? Now when you will sum it up, so you would be getting 2 multiplied by 347 plus 7 multiplied by 413 plus 243 plus 432. So we are getting over here by subtracting this 4241 minus 4363, we are getting the answer minus 122 kilojoules per mole. So this is the final answer which we are getting, and since this answer is getting with a negative sign, so this means that this reaction is overall your exothermic reaction. And now in this question it is saying the equation shows the reaction of ethene with chlorine. Now ethene is your alkene, C2H4, and C2H4 is like this. If you will draw the structural formula, so it would be like this, C2H4, and you are reacting it with the chlorine Cl2. So this time what will happen, these 2 chlorine atoms will be added on the 2 carbon atoms, and when it will be added, so you will be getting Cl over here, hydrogens, double bond will be converted into a single bond, and 1 Cl will be added on this side. So explain how this equation shows that the reaction is addition reaction. So addition reaction is the one in which the 2 reactants are added together to form a single product. So you are getting just a single product. That's why this is called a addition reaction, right? So you can write because a single product is being formed. So I hope that is clear to everyone.